Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the derivative rules to find the velocity function. So as per the problem, let S represent the position of a moving object at time t. Find the velocity v equals ds over dt at time t. So we have to find the velocity function for these three given position functions. So let's start with part A. So in part A, we are given the position function as this polynomial function or quadratic function. So we have to find the derivative of this function. And for that, we can use the Leibniz notation. So V equals, so ds over dt, which can be written as the derivative of the first term negative 2t squared over dt plus the derivative of 7t over dt. Now we have to simplify the terms. So we have to find the derivative. So we can rewrite this as v equals. Now in the first term, the negative 2 is the coefficient. So we can move it to the front and we can rewrite this as the derivative of t squared dt. So for this term, we use the constant product rule. So we move the constant outside of the term to find the derivative of the variable term. And now in the second term, we'll use the constant product rule again. So we'll move the 7 to the front and we are left with derivative of t over dt. Now in the next step, we can use the power rule to find the derivative of the first term. So for that, the exponent on t becomes the coefficient, so it becomes times 2 and t exponent 2 minus 1. And now for the second term, so it's just the variable t, so the derivative of that will be just 1. So the exponent of t is 1, so if we want to show the steps, so 7 times 1 and then t exponent 1 minus 1. So we subtract 1 from the exponent. Now we can simplify these terms. So negative 2 times 2 is negative 4 times t exponent 1, but we do not write 1 as an exponent. So this is the derivative of the first term. And then plus 7 times 1 is 7, and then t exponent 0 is equal to 1. So the term is just 7. So this is the velocity function for the position function given in part A. Now we can analyze part B. So we'll start by writing the derivative expression for this position function. So v equals, so this expression contains three terms. So we'll have to find the derivative of each of these terms. So we can start with, so derivative of 18 over dt plus the derivative of 5t over dt and then minus 1 over 3 t cubed over dt. Now we have to find the derivative of each of these terms. So the first term is a constant, 18 is a constant, so that's why the derivative of this term is 0. Now for the second term, we'll start by using the constant product rule. So we'll move the coefficient 5 to the front. So we are left with just derivative of t. And now in the third term, the coefficient is 1 over 3. So we'll move it to the front of the term. So we get the derivative of t cubed. Now in the next step, we can find the derivative of the terms. So the 0 goes away. So we start with 5. The derivative of t is just 1. So here we have to use the power rule. So the coefficient or the exponent of t is 1. So we move the exponent to the front and then we subtract 1 from the exponent. And we do the same for the second term. So we move the exponent to the front as a coefficient and we subtract 1 from the exponent. Now we can simplify the term. So we get v equals, so 5 times 1 is 5, and then t to the power 0 is equal to 1. So we are left with just 5. And then minus, now 1 over 3 times 3 is equal to 1. So, and then we are left with just t square. So we do not write 1 as a coefficient. So this should be the final answer for the velocity function for the position function given in part B. So now we can analyze part C. So I can use a different color for that. So part C. Now in part C, we are given a position function in which there is a square on the binomial. So the first step is to simplify this expression. So we can expand the square. So we can rewrite this position function as S as equal to t minus 3 times t minus 3. And now we can distribute the terms in these exponents. So we can use the FOIL method. So we get S equals, so t square minus 3t minus 3t plus 9. So t times t is t square, t times negative 3 is negative 3t, and negative 3 times t is also negative 3t, and then negative 3 times negative 3 is positive 9. Now we can combine the like terms. So negative 3t times negative 3t minus 3t is equal to negative 6t and then plus 9. So now we should apply the derivative rules to find the derivative of this position function. So we can write, so v equals, so we start by the derivative of the first term, t squared, and then minus the derivative of the second term, and then the derivative of the third term. Now, first term, we can use the power rule. So we move the exponent to the front and we subtract 1 from the exponent. And now in the second term, we can use the constant product rule. So we can move the coefficient to the front and we are left with the derivative of t. Now the third term is just a constant. So the derivative of a constant is 0. Now from the first term, we just get 2t. So the exponent is 1, but we don't write 1 as an exponent. Now in the second term, we can use the power rule. So the exponent of t is 1. So we move that 1 to the front and we subtract 1 from the exponent. And the 0 goes away. So the velocity function is 2t minus 6. So t to the power 0 is equal to 1. So this should be the final answer for the position function given in part C. So these are the steps you have to keep in mind to solve a problem like this one. So whenever you have to show your steps using derivative rules, this is how you can present your steps. So make sure you use the steps for each term in the given expression and show your steps that you're using all the derivative rules to find the derivative of the given expression. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.